Okay, so in this video we are going to calculate the moment of inertia of a solid cylinder about its central axis, so about the axis of symmetry, the main axis of the cylinder, so this axis here. So the idea, you've probably got it if you have been following the videos I made on calculating the moment of inertia of other mass distributions. The idea is to select an element, okay, that reflects the symmetry of the distribution in question, and then by integration sweep that element through the length or the surface area or the volume of the distribution to generate the full figure. Okay, so in this case we have a cylinder. So if we want to choose an element that reflects, okay, the symmetry of that cylinder, then we need to cut a thin slice. Hope you've seen that. So in this case we cut a really thin a disc that has a very small thickness dz. The cylinder has a length L and a radius of capital R. So again, the first thing we can do here is that we can write the uniform mass distribution. So we can denote by rho the mass distribution of this cylinder. That's just going to be the mass of the cylinder, capital M. So I forgot to mention that the cylinder is of mass capital M, divided by the volume of the cylinder, okay, which is just pi radius squared times the length. And then this uniform density distribution, this uniform mass distribution, can also be written in terms of the mass of the element. So here we have an element that has a mass dm, okay? So we can say that rho is also dm divided by the volume of the element. In this case, the volume of the element is just going to be pi radius squared times dz. So hope you can see that. So from here we can write that dm is equal to pi radius squared cancel, so we're going to have m over l times d dz. Is that right? Yeah, I think that's right. Okay, then what we need to do here is to calculate the moment of inertia of the cylinder. So we can say I of cylinder about the z-axis is just the integral of the moment of inertia of this disk, okay, of this thin disk. But then you remember from a previous video we did that the moment of inertia of a disk is just half mr squared, okay, moment of inertia of a disk about an axis passing through the disk and perpendicular to the plane of the disk. It's exactly what we're having here, is half mr squared. So we have to integrate that moment of inertia, so dm times r squared, okay? So this is just the integral of r squared times m over l times dz. What did I say? Half mr squared. Yeah, I forgot a half here, sorry. So this is a half here, okay. Okay, so we integrate this over z. So this is going to be equal to, I can put the constants outside of the expression, so half r squared over l, and even m can go out of the integral sign, and here I just have the integral of dz. So you see that if you want to generate the full cylinder, z needs to go from 0, so from this point, right up to this point, which is L. So we need to integrate this from 0 to L. So that's going to be half r squared over L times m times just L, okay? The integral of z is z, then you just put L. This is going to cancel that. So we're going to have I z. Let me write it here. So we're going to have I z as half mr squared. And that's the moment of inertia of a cylinder, okay, about an axis passing through the central, about the central axis of the cylinder. Okay, so hope that's clear. It's really easy. Always picture out the method. You choose an element that reflects the symmetry of the distribution. You calculate its moment of inertia, and then you integrate with the corresponding, with the appropriate, choosing the appropriate variable and the appropriate boundaries to get the result. So in the next video, we are going to see how to calculate the moment of inertia of the solid cylinder, this time about the axis IX. So an axis that's perpendicular to the cylinder, okay? So the IX and IY axis. So I see you there.